much. Thanks, Hannah. Yes, this is Chris Canfield. I am the regional sales manager for the Pacific Northwest and Southwest. I've been with OutBack for about 3 years, and AEE is one of the accounts that I manage. I'll let Ian introduce himself later. He's going to present on the FM100 with AFCI. I'm going to present first on the Northstar batteries, but Ian is one of our associate product managers, and the FM100 is his product with or without AFCI, and soon it will strictly be with AFCI. So without further ado, I will get into the Northstar batteries. First of all, a little bit of background. OutBack, as many of you know, was purchased by a group called Alpha Technologies about 10 years ago, and we've been part of the Alpha group for that long. Just a little more than a year ago, the Alpha group, including OutBack, was purchased by Enersys. And Enersys, as some of you may know, is a large global battery manufacturer. So Alpha was actually a very good customer of Enersys's. OutBack had sold Enersys batteries, for a few years. We white labeled Enersys batteries. Our RE line, if you're familiar with the RE batteries, those were and still are Enersys made batteries that are white labeled as OutBack brand batteries. So we've had a relationship with Enersys for a long time, but now we really have a relationship with them in that they are our new parent company. And Enersys recently, within the last 2 months, maybe 2.5 months at the most, acquired Northstar Batteries. Northstar Battery was, a wholly independent company of Enersys, but now has been indoctrinated into the Enersys group, and we have had those batteries available for about that amount of time, for about 2 months, as they had several renewable batteries, and those are what I'm going to talk about now, the blue and red option batteries from Northstar. Again, I think I just explained this, we just acquired Northstar not that long ago, and the blue batteries have interconnecting bus bars. The blues are the batteries that I've seen sold. I've not seen any of the reds sold yet. That's just my customers. That's certainly not all of our customers, but the blue batteries seem to be the ones that people are gravitating towards. And in fact, several customers have said that they used to purchase them from Northstar, and they still kind of are, only now it's through OutBack / Enersys. We'll start with the blues. Again, these definitely seem to be the more popular of the two batteries that we have from Northstar, the blues and the reds. I'll briefly explain the technology. I know battery technology is not, sit at the edge of your seat exciting, but it's good to have a little bit of background so you know what the battery is. There are so many lead acid batteries out there, and all of them are slightly different from each other, and that certainly includes the Northstar Blue. So I'll just briefly cover the technology behind it, but you can see they're 12-volt AGM VRLA front terminal batteries. They go from 40 up to 210 amp hours. We've got all sorts of sizes in between, 210, 190s, and again, 5 different sizes between 190s and 400s as well. So the majority of what we've sold have been the 210s or the 190s, which are obviously the highest quote-unquote power battery. So again, just a brief overview of the technology. So the advantages, or some of the advantages of the batteries, are that they're thin plate pure lead. And again, I promise I won't overbore you with this, but it allows for excellent cycle lifetime, fast recharge. That's a big plus that these batteries have. High energy throughput and space saving, because they are a relatively small size battery. There's no recharge current limit, as you can see in the bottom left there, which again, obviously helps in increasing or decreasing charge time. Can charge 5 times faster. Pure lead means no additives such as calcium or antimony, and what those additives can do is add to corrosion. So that's what leads to a longer life cycle or lifespan, if you will, of the battery as well. And in the bottom, you can see that it can operate from -40 degrees Celsius all the way up to 65 degrees Celsius. So they're pretty good, robust batteries as well. So this is what the thin plate pure lead technology looks like. The high compression plates, very small. So there are, hundreds of plates inside an individual battery. And what that allows is more energy density and a higher current acceptance, which of course leads to quicker charging. Also leads, again, being pure lead, that leads to a higher life expectancy over, your traditional lead acid battery, and makes it more tolerant to high temperatures. The life cycles of the blue batteries, 2,050 life cycles. That comes to about 6 years if you were cycling it to 50% every day. Most, if not all, lead acid batteries have a recommended depth of discharge no more than 50%. You can certainly go lower than that, but what you do when you go lower than that, obviously, is you lessen the number of actual battery cycles in its lifespan. 4,500 cycles if only used at 30%, the good batteries for multiple uses. I'm just going to touch on the ones that I have highlighted here as far as the features and benefits go. The batteries are made in the USA. One thing that Enersys is really pushing for is that they're trying to have the batteries sold in the United States and in North America really be batteries that are manufactured in the United States or North America. To my knowledge, we don't have plants in Mexico or Canada, so I believe all the North American plants are in the United States. So the batteries are made in the US. That is important to some customers. That also makes availability a little bit quicker, as far as getting them from the plant to where they need to go. Already touched on 2,050 cycles, again, about 6 years worth of daily cycling if cycled once per day for about 6 years. The design life for 12 plus years at standard conditions, of course. So they're long lasting batteries as well. I've already touched on the ultra fast recharging with, unlimited amperage. So, can be charged super fast, which is important if, you happen to have a situation where the battery needs to be cycled more than once a day. The carbon added to the negative electrodes, that increases the power and reduces sulfation. We've had other batteries with some carbon added to the pure lead before, the PLCs, which we no longer sell. So some of you, if not all of you, may be a little bit familiar with that technology, but it basically just makes for a cleaner, longer lasting battery. The applications for the blue battery, we think it's ideal in all three, if you will, of our main applications, off-grid, grid-tied for backup, or self-consumption. It will absolutely be a good battery in all three of those types of installations. The Northstar Red, the technology is the same, so there's no reason to go over it again. You can see these are a little bit, well, the main difference is the cycle life. They cost quite a bit less, as you would imagine. I would say with only 750 cycles at 50% depth of discharge, we say that, this can be used again in all three of the situations that the blue batteries can be used in. But honestly, with a 750 cycle lifespan, you probably would use this mostly for backup. Same bullet points really as last time. The difference is, again, being 750 life cycles. That would be only 2 years. So if it were cycled daily at 50%. So again, probably not a battery that you would have in an off-grid situation or a situation where you would fully, reach that 50% depth of discharge every day, because you'd be replacing these batteries in 2 years. They're designed to last a long time. And again, that's why I think they are very good batteries for backup, but primarily for backup. And that's it on the new batteries that we're selling, the Northstar batteries. We still have all the other batteries available, of course. But at this point, I am going to, give me just a second, Ian. I'm going to turn the presentation over to Ian so that he can discuss our exciting new product. The FlexMax 100, of course, has been around for a while, but now it is available with AFCI. And Ian, I believe I switched it over to you. Let me know if that worked. There it goes.
All right, you did, and I believe I'm presenting the right screen. All right, so thank you, Chris. Thank you, Hannah. This is Ian at OutBack Power. I am right in the middle of releasing this FlexMax, or we are rather, it's a team effort for sure, releasing this new charge controller with arc fault built in. And I wouldn't be surprised if some of the folks on the webinar have seen material on this product. We showed it off at STI, but I'm going to focus on code compliance. With NEC 2017 in California right around the corner, and you know, as I understand, already starting in some areas, I wanted to focus on that. So let's go ahead and get started. Chris gave me plenty of time to work with, so I will make sure that we get a good overview here. So first, we're going to start with the overview of the product, then we're going to talk about compliance, and then we will talk about our integrated system options, which are updated for this new charge controller. So we broke it down into 4 major features, or yeah, you could call them features. First one, our latest integrations to maximize return on investment, you know, which is a huge priority for solar energy customers at this point in the market. You know, in product adoption, return on investment is really the key that homeowners are looking for, and reliability, of course, which plays into that return on investment. So our latest load centers, flex powers, and system edge packages are updated with this product. Those are coming out this month, or well, December. So in December, and the simplified NEC 2017 module level rapid shutdown devices are included in those system edge packages. So even if a particular system edge package doesn't work for you exactly, those packages serve as good templates for a bill of materials that you would need for a module level rapid shutdown system. It's engineered for reliability with a 5-year warranty. We've put both generations, the first and second generation, through highly accelerated life cycle testing, and it is built with a NEMA 3R enclosure, so it can be installed in marine environments, dusty environments, sandy environments, outdoors. It meets NEC 2014 and NEC 2017 requirements. Has arc fault, ground fault, and rapid shutdown requirements all built in, all on board. And we've updated the MPPT algorithm a bit so that it achieves a cell state faster in grid connected systems. I think this is the easiest way to, you know, explain the benefit of an updated and advanced MPPT algorithm is that when it's grid connected, you'll be selling more energy, and when it's off grid, your batteries will charge up faster during the day. And I get a question a lot here on the sweep rate, and so I looked into it a little bit, and efficiency. You know, where's the efficiency peak and what's the sweep rate? I looked into it with the engineers. Essentially, the sweep rate is dynamic. So the sweep rate changes. It goes up as the power increases and the solar is fluctuating. So if the solar input, you know, if the power from the solar array is changing frequently, the sweep rate will actually dynamically speed up to accommodate that. And when the power from the PV is low, or it's not changing frequently, the sweep rate will slow down. And the peak efficiency is around 220 volts or so. So right in that's right in the sweet spot where, you know, your average array, if it's sized appropriately for the charge controller, will sit on a good sunny standard conditions day. So your peak efficiency sits right around the standard array size, which, you know, we recommend anywhere between, we warranty up to 7,000 watts. You know, the most common size I see on this charge controller is about 6,000 watts, but if you're in a warm environment or if you really need that extra PV, up to 7,000 watts is under warranty. So what's new on this charge controller? Well, primarily the arc fault circuit detection and interrupter is built in. Listed the UL1699B with local and remote indication. Max input of 7,000 watts with continuous output at 100 amps and 6,000 watts of charging. What that really means is 100 amps of charging at your battery voltage. So if your battery charges at over 60 volts, then you would get over 6,000 watts of charging. But it's an easy, you know, number to put on the output. The enhanced MPPT algorithm is new. Rated for 300 volts of PV, active cooling, outdoor rated, built-in ground fault protection, which was not new on this generation, but new compared to our other charge controllers. So you no longer need the old green GFDI breaker in the load center. You can use any standard breaker for the ground fault. And and field upgradable firmware. So this is a nice benefit compared to the FM60s and the FM80s, which have to be sent in for firmware upgrades. The FM100 can update in the field either through the gateway or directly through the SD card, which plugs in the wiring compartment. And for NEC 2017 compliant systems, we calculate an approximately $1,000 cost savings per charge controller to comply with NEC 2017 compared to the previous generation, and really any charge controller that doesn't come with arc fault built in. Keeping in mind that the price on this charge controller did not change, so that's a nice benefit. Here are the specs. I won't, read these out, but feel free to. I'll give everybody a moment here to look over these, and if you have any questions, please write them in. 99% efficiency is big. We have a lot of really good feedback on the efficiency on this product, and that it really does live up to expectations. Here's a nice comparison, and this was something that we were encouraged to do by installers. They asked, hey, we noticed that the input and the output on this charge controller is really well matched, right? Instead of being some really high input voltage but low output current, we had 300 volts in and 100 amps out is a nice size match. So we thought, let's find out what that actually would create, what sort of energy harvest difference that makes over the course of a year. So we ran a simulation in Los Angeles, and when you look at the power output on a 7,000 watt PV array in Los Angeles, you see a pretty significant peak difference there, right? With the 100 amps output, you're charging, at a nominal, say 5,200 watts output. If you're selling, if this is a grid connected system, of course, you're able to sell back to the grid here, so you don't have to worry about curtailment there. That hourly output is going to be significantly higher over the course of the day. And over the course of the day, in terms of storage output or kilowatt hours, the actual energy produced, that's a pretty significant difference. That's about 500 watt hours. And if you run that simulation over the course of an entire year, this is a day in the summer. So in the winter, the difference isn't quite as significant, but still, in the course of 12 months, you're looking at almost a megawatt hour difference of energy harvested, which really adds up in terms of revenue, right? In terms of net metering revenue or cost savings, if it's a self-consumption sort of situation. So there's a pretty significant difference in energy output over the course of a year when you have that really appropriate 300 volt input, 100 amp output size match. You can see installer on the right, he agrees with that assessment. He's very happy. So moving on to the nitty gritty, past the sales pitch, let's talk about NEC 2017, which is just a blast, with these module level devices on the roof. I'll quickly review each letter. So A, B, and C, ground fault, arc fault, and rapid shutdown are all built into the charge controller. D is an optional rapid shutdown. And I think this is a really important point. It's something that actually I didn't know before starting at OutBack, but OutBack is, as far as I know, the only company that offers this option, which is not required by code, and that is that the inverter itself will de-energize the backed up loads panel if you decide to use this optional rapid shutdown to the inverter. Why is that important? Well, firefighters typically don't go through the roof. So the reality is that this rooftop requirement with these module level devices in the most areas will never actually come into play because firefighters typically do not climb on roofs anymore, but they will go through walls inside the house. So in a backup system with a backup inverter that's going to energize loads in the case of a grid outage, the firefighters come and they shut down the main service panel, and the inverter kicks on to energize the backed up loads, and those firefighters go through the wall. They're actually at risk of being shocked by the backed up load panel or the backed up loads. Whereas with the Radian, you have this option to install just a simple twisted pair to the inverter, and that will de-energize the inverter and the backed up loads panel. So this is, this depends on your customer preference, and it's, again, not required by code, but it is, worth keeping in mind in certain areas and in certain applications. It might make sense. The controlled conductor here is, that's code speak for the PV home run, essentially, that goes up to the rapid shutdown devices. F, PV disconnect, of course. G, the disconnecting means for your batteries. And H is just the power supply for the rapid shutdown initiator. So this is just one option, one of our rapid shutdown configuration options. We'll look at a few in a few slides here. We'll look at a few different options. And of course, rapid shutdown control I is just the signal wires from the charge controller to the rapid shutdown. In case anybody is joining in from Canada, we know that in Canada, the rule was not changed to 30 seconds. So it's still 10 seconds in Canada for rapid shutdown. This charge controller will bleed down its capacitors and de-energize the entire controlled conductor in less than 1 second to below 30 volts. So it's a very rapid shutdown response and is compliant both in the US and Canada, unlike most other options on the market. So here's a quick animation. We can see hopefully this animation shows up on everybody's screen. We can see the red, symbolizes the current. It's current passing up here, current return current on the negative, and we have a circuit here. We have a PV circuit. Okay, so looking here is our sensor coil that we'll see in a moment, and we have our PV positive, PV negative, battery positive is not shown, and then our arc fault printed circuit board. This is our arc fault detection board connected to the DSP. So that's the control board in the charge controller. This sensor coil is looking out for an arc fault, and oh no, arc fault happens, right? Maybe a squirrel got up, the friendly neighborhood squirrel decided it would try the taste of PV wires and an unfortunate accident. So we see that arc fault signal traveled down the conductor, went through the sensor coil. Sensor coil communicated that arc fault signature to the board. And this is a dual algorithm board, so it has a virtually 0% chance of false arc fault trips. So you can be sure that if an arc fault event occurs with one of these new charge controllers, it's a real arc fault. There is an actual arc noise occurring somewhere on the circuit, not just a noisy load or something like that. That arc fault board informs the DSP, which shuts down the entire circuit in less than a second. We're talking, a few microseconds is how long this takes. It de-energizes the whole system. So what does that mean for compliance? Well, it's good news, certainly. Now, instead of having to deal with the big $1,200, $1,500 rooftop combiner with arc fault built in, if you're using only 2 strings, which is possible with a 300 volt charge controller, if you don't need a ton of PV, these Y connectors work. I think I got this image off of Google, so I don't know what brand that is, but I'm sure AE carries Y branch connectors, or our low cost. This is our low cost combiner. Of course, there are other low cost rooftop combiners on the market, but this is our low cost version that comes with the fuse holders installed, FWPV6 FH600. So this is instead of the big ICS Plus packages that we've sold for the last couple of years to comply with NEC 2014. And this is where that $1,000 plus savings comes in. Both of these options are very inexpensive compared to the ICS Plus. So here are the 3 different packages that we sort of, the most standard packages. The key is this one is good for up to 40. So I'll quickly go over this before I go into the details. This one is up to 40 modules based on the power supply inside of this Fire Raptor switch. And I believe AE has a number of these in inventory now. This Fire Raptor switch can power up to 40 modules, which is enough for at least 2 FM100s, typically, maybe 3, but generally 2. So that's, majority of installs will be covered by this one. This package can power up to 110. So that's more like 6 FM100 charge controllers off of a single switch. And of course, keeping in mind that for rapid shutdown requirements, you can have up to 6 disconnects. So it's easy enough to, even if you want to use this package, if you need more than 2 charge controllers, buy a second switch. This switch is really inexpensive as well. It's very very inexpensive product. So instead of upgrading to this, there's also that option of just buying a second switch with a second power supply inside of it. The third option, of course, is Tigo, and we are testing with a couple of other Tigo products, but at this point, the TS4-S is the only one with the UL listing. So the TS4-S for safety module is available as well with the Cloud Connect package, which offers module level monitoring. So some customers, you know, if you have customers that are particularly interested in that module level monitoring, this is a good option. It's certainly more expensive than the IMO, but it's still a good option for certain circumstances. So let's look at,
Ian, this is Chris. Sorry, just to jump in, I apologize if you mentioned this, but we sell the IMO rapid shutdown system through OutBack. We don't even white label it. We just buy it and resell it. So AEE has that available, and AEE can order that directly from us. So it's a real simple transaction. The Tigo stuff we do not resell. So that would be for AEE, at least that would be a separate transaction. And we've been seeing AEE buy, and obviously they're selling quite a bit of the IMO Fire Raptor, so it must be working pretty well out in the field.
Yeah, and usually thank you, Chris. One thing I forgot to mention about IMO is a very large industrial control company. The Fire Raptor is their module level shutdown solution, but they make extremely reliable products. And in fact, IMO products like connectors and switches and that sort of thing are in the majority of solar inverters on the market. So most of the most common brands out there in the field contain IMO components. And IMO is really a very, very reliable product. The mechanics inside of those, these IMO Fire Raptors are so simple that the warranty it's 25-year warranty on those. I should double check that, but it's 25 or 20. I think it's 25, but it's definitely at least 20 years on those. And the mechanics inside are so simple. There's no capacitors or anything like that. They're very basic design, and they work really well for what they do at a nice low cost. So let's look at a quick line diagram. I have 3 line diagrams, but we'll only focus on the first one, and then we'll kind of look quickly at the next 2. And if anybody wants to revisit these at the end in more detail, I'm happy to do that. So we have a charge controller here. You have your IMO power supply here, and you have your AC out bus here. So let's start with the source of power. The AC out in the GS load center provides AC to the IMO power supply switch. The IMO power supply switch feeds the power in, power out terminals on the Fire Raptor. So that's, you can't see them in this photo, but on the bottom of this device, there's a power in, power out labeled connection points. Then those are strung together, just standard daisy chain configuration. On the other side of this circuit, there's this relay. So this relay here, this is the OBR 1624 DIN. It's just a basic relay. And that relay primarily powers the rapid shutdown circuit on the FM100. So when the switch when somebody hits the switch, it will de-energize, or rather it will open this circuit. And that circuit, by de-energizing the relay, it'll open this circuit, and that circuit will open the rapid shutdown circuit of the FM100, thereby causing the FM100 to go into rapid shutdown mode, sending a rapid shutdown event signal to optics, the web monitoring system, and signaling rapid shutdown on the charge controller itself. This is the optional inverter on-off circuit over here. So this is the circuit that shuts down the inverter if your customer prefers that option. If the end user prefers that option. The charge control, or the Fire Raptors, of course, are part of the PV home run now, and they go through this low-cost combiner. This is an FWPV4, another option. FWPV4, FWPV6. This is the 4-string version, which goes through the PV disconnect, of course, in the load center to the charge controller. So give everybody a moment here to look over this and see if there's any questions before I look at the next one. And one other thing worth mentioning, and it took me a moment to wrap my head around it when I first saw this product, even if there are multiple strings, so say there were 2 charge controllers in this circuit, right? This power supply, this blue conductor up here, this can daisy chain to all of the Fire Raptors. They're going to be on 2 different home runs, but the power in, power out is independent of the string in, string out. So you can daisy chain all of the fire raptors on the roof down to the single rapid shutdown switch, even if they're on multiple charge controllers and multiple home runs. All right, let's look at the next one. So this is the larger system. Typically, you would only use this configuration for more than 2 charge controllers with the RSI. And it is a little bit, and arguably it's less complex, and there's less components, right? All you need is the power supply in the radian, or in the load center, connected to the rapid shutdown switch. And that rapid shutdown switch powers the power in, power out on the fire raptors, just like the previous switch did. And they have the same configuration with the home run. And then, of course, the J3 on the RSI, which has been out for several, many folks are familiar with this product. The J3 is what opens the circuit to the charge controller, thereby shutting off the charge controller, putting it into a rapid shutdown event. And this can be either used to daisy chain to the next charge controller, the second yellow and purple terminals there, or it can go straight to the inverter on off, or it can do both in that you daisy chain as many charge controllers as you want and then go to the inverter on off. This is the Tigo version with the rooftop TAPs. So very similar to the last version. I mean, the only difference here is that on the output side, instead of going to the rooftop Fire Raptor modules, it's going straight to the Tigo CCA, which connects to the rooftop TAPs. Can never remember what the TAP acronym is, but that mesh network on the roof, and then those connect to the Tigo safety modules, which cause rapid shutdown event if this switch is turned. It's very similar to the last one there. The only difference is the rooftop device, basically. All right, moving on from the line diagrams, we'll look at a quick example BOM. So here's the old version, here's the new version. Old version, Fire Raptor shutdown devices, and an ESW switch. This is what you would need for NEC 2017, basically this list. So you get your devices and your switch. You would need your AFCI rapid shutdown combiner box, which is very expensive. Not an expensive solution for the rooftop, and that contains the AFCI. You need your RSI switch, and you need your power supply. In the new version, for most installs, right, all you need is your charge controller, your devices, a standard low-cost combiner box, the relay, which is also very inexpensive, and this breaker is technically required for, I forgot to mention that. So here, this little guy, this is a 1 amp breaker or fuse to this power supply, just for safety. But all of these three especially are very low cost compared to the ICS Plus RSI switch and power supply that you would need over here. So this is the difference of over $1,000 per charge controller to comply with NEC 2017 with the new product. And lastly, we'll talk about integrated systems options. So our GSLC part numbers won't change. The wiring changes a little bit inside of them. And we had a webinar a couple days ago on wiring differences. The main difference is that on the new charge controller, you want to isolate the PV negative. Typically in OutBack systems in the past, the PV negative was common to the rest of the negative in the DC negative in the system. Now, by isolating the PV negative, you ensure that there's less common mode noise, electric interference on the negative, so that the arc fault device will have, like I said, virtually 0% chance of false tripping if that negative is isolated. So the part numbers won't change, but the wiring will change a little bit, and the PV negative will pass. There will be a direct connection from the PV negative to the charge controller instead of the common bus. Here's an example of one of the new flex powers. This is the 8 kilowatt flex power with a new charge controller. It's got 6,000 watts more PV capacity than the FM80 versions, which is equivalent to roughly 18 more PV modules. One thing that's worth mentioning, and this is partially thanks to Chris, we will also have an 8 kilowatt version with a single charge controller, which is already actually proven to be a popular option. We have some sort of pre-orders for that version, which is the 8 kilowatt with a single charge controller or 7,000 watts of PV. So in a situation where you don't need a ton of PV, where the primary concern is having that 8 kilowatts of output, but maybe the roof space is limited or the customer just doesn't need a huge array, you can cut down on the cost of this flex power by getting the full 8 kilowatts of inverter and 7,000 watts of PV instead of 14,000 watts of PV. And that's this unit right here, the LT. For lack of a better name, we called it the LT for light, the single charge controller. We had to keep it within the 14 character limit for our part numbers, so thought that worked. And then of course we'll have the Flex Power 2s, the popular Flex Power 2s as well. So there's 5 options here for Flex Powers with the new charge controller. System Edge pre-bundled package. Of course, we've had System Edges for some time now, and our battery options have changed a few times. This is a XLC, the 1000 XLC, large high-capacity battery, advanced sealed lead acid popular battery. It comes with the IMO Fire Raptors and, of course, optics and the new charge controllers. And these are the 5. The only systems that are missing from here, actually, I wasn't able to add them, are the Blue Plus. We're working on the designs for the Blue Plus system edges as well. What we'll probably have are similar to the PLR. So we'll probably have a 420 Blue and an 830 Blue with the new arc fault charge controllers with the same capacity, and that'll be good for cycling. These PLRs are great backup batteries. The Blues will be the cycling battery options. And then of course we also have this 860 XLC. So this is a pretty boss, beastly system here with 60 kilowatt hours of capacity, 8 kilowatts of output, and 14,000 watts of PV. So that's for folks who really want a really large, reliable system. And this one actually, importantly, comes with a 10-year warranty. So this system edge here has the full system 10-year warranty on that battery, the flex power, and all of the accessories. Also important, in California, we are now UL 9540 listed with the Simplify and our IBR. So any Simplify battery and our IBR, the 3.5 and the 3.8 kilowatt hour versions, are both listed to 9540 with any of our UL 1741 SA inverters. So that's the Radiant, FXR, all of our charge controllers, Skybox are all 9540 listed in conjunction with this package now. That's a nice addition now that UL 9540 is starting to kick in California. It's not really relevant in other places yet. We might see that happen, and we are working on expanding our UL 9540 listings with other batteries, in particular the PLR and the Blue Plus. So we'll have backup and cycling options. And yes, you heard that right. Those are not lithium ion, but they will be 9540 listed shortly here. So that is moving forward. So quick resume. We have a built-in NEC 2017 compliance, latest innovations in reliability, 300 volt input and 100 watt amp output. And in general, the FlexMax 100 is the high power integrated solution for the new NEC 2017 solar industry. And yes, it is available now. The official go-to-market is on December 9th, is when this will be announced for general availability. But we have been releasing information, and AEE has had some experience with this charge controller in the field trial stage. So we have a large number of these units out in the field for trials, and tens of thousands of hours of trials, plus hundreds of thousands of hours of lab trials. So we're really happy with the state of this project, or the state of the product and its stability, and we're going to market on December 9th. So get ready. And we are ready for any questions.
All right, thanks, Chris and Ian. We will start off our Q&A session here. So for anyone on the line, if you have any questions, feel free to shoot them over, and we'll get through those here with the time we have left. Just a quick reminder, while we wait for those questions to come in, you can exit the webinar at any time. And just remember that survey will pop up in a new window once you exit the webinar. So complete that quick survey and we'll send you a copy of these slides. If you missed the pop-up, you will get an email an hour after the webinar ends that will also have the link to the survey. So you'll have a couple chances there. All right. Well, we'll get down to some questions here. The first one we have, Ian, this one was on one of your slides, I think towards the beginning, asking to expand on the $1,000 savings per CC comment.
Yeah, I think we briefly covered that, but I think the best slide to illustrate is here, the bill of materials difference. So for NEC 2017 with the previous charge controller, you're going to need, this is going to cost the same amount, right? These two charge controllers, the new version and the old version, are the same price. The Fire Raptors, of course, are the same price. But instead of this standard combiner box and the low-cost relay and breaker, with the old charge controller, you needed also the ICS Plus, which is well over $1,000